Hello, welcome to this lecture video. So our purpose for this video is to come up with the trend line of this given data. So the rate in dollars from 1991 to 2009. So to do that, we can actually use recommended chart. So just to come up with the trend line of this, the appropriate is just to make a line chart for our data. So let us do that. So we can select this and simply check recommended chart, and you can see here our trend. So this is now the trend. So as you can see here, it is fluctuating. So you can also change the colors of your trend if you do not like it to be this or either the design. So you can select here. So what do you prefer? You can also include the values. So this is how to make the trend line. So you can just copy this and paste it in a separate document. So this is for the trend line. Next, how will we, let us place in a separate sheet all the data that we finish. So this is the trend. Let's place the trend here. Next, our next objective is to come up also with all other models. So to do that, so we can just simply remove this. Anyway, it's already here. So what we need to do is to create a scatter diagram of this data. So by simply clicking insert and then scattered diagram and this one. So this is the scattered diagram. This is actually the same chart with the trend line, except that we do not have the numbers here or the year here anymore because it's already coded with these values. So what we will do is to click this, click the dots, right click and add trend line. So as you can see here on the right side, we have the trend line option. So we have the exponential, linear, logarithmic, polynomial, power, moving average, and also you can tick the equation to display the equation and to display the r squared value on the chart. So let us do that. So first, let us do exponential. So this is the exponential, and let's check display equation and display r squared. So this is the equation and the r squared. Okay, so next, so let us again copy this and paste it here. So this is the graph or the chart that we need. And then next, how about in editing this? So we can edit this by just simply removing our trend line, right click again, add trend line, and let us also do the linear. So what you need to do is also to check display equation on chart and display the r squared. So what is missing here is the value of the standard error, because when you are determining for the best fit model, what you need to see is the value of r squared as much as possible. We have a very high value of r squared and very low value of the standard error. So let us copy this and place it here. So this is our linear. And then next, let's go back. So let's remove this. And again, right click, add trend line. Let us also choose logarithmic. So do the same procedure, check display equation on chart and display r squared value. And copy this and paste again in our sheet number 2 so that it is easily for us to go back to our data. Then followed by, so if we also need to, if we also need to generate all other chart, or rather all other trend line, so we are already done with the 3. How about for polynomial? So for polynomial, if you can see here, we have the value 2. So which means this is quadratic. So when we are, the polynomial order 2 is the quadratic equation. So let us again check the display equation and display r squared and place it here. So let us copy this and paste it here. So we're done with our logarithmic. Next, let's go back. So right click, add trend lines. Let us also choose, it's polynomial rather, it's quadratic. Let us also choose number 3. So cubic. Let's check the display equation on chart and this. And then let's observe what happens to the value of r squared. So from quadratic to cubic, so let us take this and paste it here. Okay, so from 0.3606, so it becomes 0.3649. So which means we can still continue to explore, but in case that you notice that the value is decreasing as you move or as you increase the value of our trend line, then it is okay not to include other polynomial functions anymore. So let us also change this to 4 and tick display equation, and the other one display r squared. So it is really increasing. So it is now 0.3758. And let us continue with all other charts. So add trend line. And so again, in polynomial, we're done with the first raise up order 4, order 5. Check this. Okay, so copy and paste it here. So let us check. We have quadratic, cubic, and then power of 4, power of 5. So as you notice, the value of r is increasing. So if you cannot see that, let me just read it. So from the value of, let's see, this is the value 0.36 to the value now is, let's go back to our last chart. It is 0.7664. So as observed, it is increasing. Okay. So we have the fifth order. Let us also consider sixth order. So what we need to do is to go to sheet number 1, and so we will change this to right click, add trend line, and polynomial raised to 6. So until this is, Microsoft Excel can generate until order number 6. So you have to check display equation again. So this is the next equation. So what you need to do is to copy and paste. Okay, next. So what else do we need to do? So we are actually done with order 2 to order 6. So the next thing is, so we still have here power. So just click it and then display equation, display r squared. Okay, so this is our graph with the trend line. And then next, let us also generate the moving average. So as observed here, we still have one more trend line left aside from what is already done. So add trend line, we have exponential, we're done with exponential, we're done with linear, logarithmic, polynomials order 2 to 6, power, and we have the moving average. So in the moving average, the period here too means that you're going to add the first previous two data and then divide it into 2, so get the average. So it's moving average. So if you make it 3, it means that you're going to consider the 3 previous data. So let us use 2. And here we cannot generate the display equation and the r squared. So it is not applicable. So let's go back. So is this the value? Okay, let's repeat doing it. Add trend line and moving average order 2. So this is the value. So if you add this to the average is this point and so on until you reach this part. Okay, so let's copy this and paste it in our graph. So this is the complete set of our tables that can be generated using the Microsoft Excel. If we will just limit it into constructing the scatter diagram and then right click, click trend line, and then just select the trend line of your choice. So if you want to explore everything, then you can do that. And then you can also tick the r squared so that you can see also the value of the r squared. So as mentioned, aside from the values of this, aside from the equation, aside from the value of r squared, one important thing is also to determine the standard error. So which means, for example, in the sheet number 1, so let us use this. So for sheet number 1, so this is the value. So for me to determine the predicted value using the linear, so let's allocate for the equation of the linear. So this is the equation of the linear. So let's copy it here. Okay, so my concern is just the formula. So the formula is y is equal to a negative 0.1704 x plus 5.2837. So to compute for the predicted value, so you have to substitute for the value of, so we need, of course, to do the equation here, to place the equation. So let us just make this larger. So equal sign negative 0.1704 multiplied by the value of x is the time. So I placed here 1 that corresponds to the value of 1991. So I'll use this. So plus 5.2837. So you can actually place an open and close parenthesis here to indicate the this is the negative 0.1704x and click OK. So this is the predicted value. So since we are actually using the same formula for all of the values here, except that C3 will become C4, C5 because it will represent now 2, 3, 4, and so on. So you need to drag this down so that you can also get the predicted value for this. And then next, if you still recall the equation of the standard error, so we are also going to compute for that. So the standard error, so we are going to get the difference between the rate, the actual value, minus the predicted value and get the square of the result. So this is raised to 2 equal sign. So again, the formula for a standard error, so initially, or the first step is just to get the difference and then the square, and square the result. So you just need to drag this down until to the last data. And then get the sum. Because it is the summation of the difference. And after that, you have to divide this by n minus 2. N minus 2, n is 19. You have 19 data. Minus 2 is 17. So over 17. And get the square root, equal sign, SQRT, open parenthesis, and this value, close parenthesis, enter. So this is the standard error. It's 1.47. So we obtain the value of y, or rather we obtain the equation, the trend line. This is the trend line. And we also computed for the value of the standard error. This is the value of the standard error. And then the next thing is that, of course, you are already provided with R squared when you use it. So what you need to do is to summarize it in a table in such a way that you can see the value of R squared, and you can also see the value of the standard error. But you need to compute the standard error first for each of all the data, or for each of all the graph that you considered, or the, what do you call this, the equations, the model that you considered in this problem. So what we considered are the available data or the available equations in Microsoft Excel. So this is all for this video. So thank you for watching.